Myself, Vijaya, Assistant Professor, Department of Computer Science and Engineering, Shriram Engineering College, Tirupur. Now I discuss about interprocess communication in operating system. Interprocess communications process executing concurrently in the operating system may be either independent process or cooperating process. A process is independent if it cannot affected or be affected by other process executing in the systems, whereas a process is cooperating if it can affect or be affected by other process executing in the operating system. Need of cooperating process. First one, information sharing. In information sharing, several users may be interested in the same piece of information. Here we must provide an environment to allow the concurrent access to such information. Second one, computation speed up. In computation speed up, if we want a particular task to run faster, we must break it into subtasks, each of which will be executing in parallel with the others. Notice that such a speed up can be achieved only if the computer has multiple processing areas. Third one, modularity. In modularity, we may want to construct the system in a modular way, dividing the system function into separate processes. Fourth one, convenience. Convenience, even an individual user may work on many tasks at the same time. For instance, a user may be editing, listening to music, and compiling in parallel. This picture shows two ways that two processes can communicate with each other in operating system. Figure A shows the message passing, B shows the shared memory. In figure A, message passing, the process send message to each other through the operating system, that is kernels. Here, process A create a message. Next, the message goes into a message queue inside the kernel. Process B read the message from the queue. If process B want to replay, it send another message through the kernel. In B, by using shared memory, the process share the same memory area and rewrite data directly. Here, the operating system create the shared memory region. Both process A and process B can access it. Process A write data into shared memory and process B reach the data directly from shared memory. In shared memory system, say for example, producer consumer problem is the best example for shared memory systems. The producer consumer problem is a common synchronization problem in operating systems. Here the producer put item into the buffer and consumer take item from the buffer. On types of buffer, first one, unbounded buffer. In unbounded buffer places the no practical limit on the size of buffer. The consumer may have the wait for new items, but the producer can always produce new items. In bounded buffer, it assumes a fixed buffer size. In this case, the consumer must wait if the buffer is empty, and producer must wait if the buffer is full. In message passing, here message passing provides a mechanism to allow the process to communicate and to synchronize their action without sharing the same address space. In message passing performed two operations. In send message, in send message operations sends message to the receivers. In receiver operations receive the message from the senders. Here message size is either fixed or variable. In direct communications, process must name each other explicitly. Here in direct communications, in send process send a message to the process B, whereas receiver receive a message from the process Q. Here some properties established by the direct communications. First property is links are established automatically. Second property, a link is associated with exactly one pair of communicating process. Third one, between each pair there exists exactly one link. At final, the link may be unidirectional, but it is usually bidirectional. In indirect communications, messages are directed and received from mailbox. Each mailbox has a unique ID. Process can communicate only if they share a mailbox. Here, properties of communication links are: first one, links established only if process share common mailbox. Second, properties are: a link may be associated with many processes. Third one, each pair of process may share several communication links. At final, link may be unidirectional or bidirectional. Next is synchronizations. In synchronization, message passing may be either blocking or non-blocking. Here, blocking is considered synchronous, whereas non-blocking is considered as asynchronous. In blocking, the sender is blocked until message is received. In blocking receive, the receiver is blocked until message is available. In non-blocking send, the sender is send the message and continue. On non-blocking in non-blocking receive, the receiver receive either valid message or null message. Buffering, buffering queue of message is attached to the link. It can be implemented in three ways. First one, in zero capacity, no messages are queued in on a link. Sender must wait for receiver. In bounded capacity, finite length of n messages. Sender must wait if link full. Third one, unbounded capacity. In unbounded capacity, in is infinite length and sender never wait. Thank you.